Hi everyone, this is me Atini. Welcome to our next chemistry lecture. In today's lecture, we are going to discuss about acid-base behavior of the oxide of period 3 element. Before going to start our lecture, I would like to tell it is chapter number 13 of second year first chapter S&P block element, and our lecture number 6. In lecture number 6, we will discuss acid-base behavior of the oxide of period 3 element. So first of all, few points are present we must understand about this, about acid and base, how like across the period, across third period element, acidic properties increases from left to right. From sodium to argon, acidic properties are increases. Clear? Acidic properties increases. In this point it tell us like this. Clear? Across third period element, acidic properties increases from left to right. Second point, the basic characters of the oxides of the property of period 3 elements decreases. Clear? Here whenever we go from sodium to argon, clear, basic properties that is decreases during this point. Clear? The basic character of the oxide of period 3 element decreases. Reason why they decrease and why acidic properties increases from left to right. Clear? Reason, non-metallic properties increases. Here non-metallic properties, here sodium is metal, it is metallic, it show metallic properties, but argon show non-metallic properties here. Clear? So this is the point. Also increases electronegativity from sodium to argon. Here in sodium no electron negativity, less electronegativity, but in argon more electron negativity. Clear? Non-metallic are acidic and metals are basic in nature. Sodium is here, it is metal. Clear? So metals show basic properties. Here metals show basic, but non-metals they show acidic natures. Here argon is non-metal. Clear? So that's why it show acidic properties. First A and second A, they are metals, that's why they show basic properties, and other members they show acidic properties. And few points are present here. The sodium oxide and magnesium oxide are basic in nature. Clear? So it's already we know in this point, when they react with water they form hydroxide ion. Whenever first A and second A metals they react with water they form hydroxide ion, OH. Clear? Ion is produced or formed, while ammonium oxide is amphoteric in nature. Amphoteric means which have both the characters, which have both the properties of metals and non-metals. So that's why they are called amphoterics. In ammonium oxide both the properties, metals properties as well and non-metals properties are as well present. Next point, the silicon dioxide or phosphorus dicoxide and silicon trioxides are acidic in nature. These three are acidic in nature because they are present, they are near to argon. Clear? They are not in first A and second A. So that's why they are away, they are present in P block elements, they are non-metals. So that's why they are acidic. So these were a few points which I deliver. So now we are coming to our topic which is very important in this lecture, that is reaction of oxide with water. First with water, second with acid, and third that is with base. Clear? Oxide, how they react with water, with acid, and third with base. So let's see reaction of the oxide with water. Our first point, that is with water, reaction of the oxide with water. Whenever sodium react with water to form basic solution. Clear? So these we discussed in our previous lecture. Clear? So whenever the first and second A metals they react with water they form alkalis, means strong base they produce here. So the same point again it deliver here, it's again repeat here. Sodium react with water to form basic solution with the pH solution is 14. Here it make a neutral solution, pH is 14. Whenever sodium oxide react with water it produces sodium hydroxide, and magnesium react with water to form basic solution, but it's slow process and with a pH of 9. Aluminum whenever it react with water, aluminum oxide. So it's a slow process, clear, and with a pH of 9. So magnesium with water, magnesium hydroxide, ammonium trioxide, whenever react with water, so no reaction take place. Reason, insoluble in water. Directly it is not soluble in water. Next point, silicon dioxide with water, no reaction take place due to giant covalent structure. So that's why more energy required, that's why it cannot react with water. Next point, our next point, that is phosphorus hexoxide. Whenever react with water, it produces phosphorus acid. Whenever phosphorus dioxide react with water, it produces phosphoric acid. And sulfur oxide react with water, it produces sulfuric acid. And sulfur trioxide react with water, it produces sulfuric acid. And next point, that is chlorine dichlorooxide. Whenever react with water, it produces hypochlorous acid. And dichloroheptoxide react with water, it produces perchloric acid. So this was the oxide, how they were reacting with water. So now we are coming to our next point, that is reaction of the oxide with acid. How oxide react with acid, it is our second point. Sodium oxide react with dilute hydroxide. Dilute, one is concentrated and one is dilute. In dilute, waters are present, water is present in dilute, so that's why dilute hydrochloric acid to form aqueous solution of the sodium chloride. How, like whenever sodium oxide react with dilute HCl, it produces sodium chloride plus water. And so magnesium oxide react with HCl, it produces magnesium chloride plus water in warm condition. And third, that is ammonium trichloride. Whenever react with HCl, it produces ammonium trichloride plus water. And next point, that is silicon oxide. Whenever react with HF, silicon oxide cannot react with common acid, but it react with HF, so it produces tetrafluorosilane plus water. Clear? Tetrafluorosilane plus water is produced. Whenever tetrafluorosilane react with HF, again it produces hexafluorosilicic acid. Clear? So this was the reaction of the acid, how they were reacting with oxide. Next point, our third point, last point, that is reaction of the oxide with base. Whenever ammonium oxide react with sodium hydroxide plus water to form sodium tetrahydroxoaluminate. How, like ammonium oxide react with the sodium hydroxide plus water, it produces sodium tetrahydroxyl aluminate or aluminum. Clear? So next point, silicon oxide react with sodium hydroxide, it produces sodium trisilicate. It is silicon dioxide react with sodium hydroxide, produces sodium trioxide or plus hydrogen plus water. Next point, that is sulfur oxide react with sodium oxide, it produces sodium sulfate plus water. And whenever dichlorooxide react with sodium hydroxide, it produces sodium hypochlorite plus water is produced. So this was my lecture which I delivered in the front of you, lecture number 6, that was acid base behavior of oxide of period 3 element. So this was my period. So see you, thanks for listening my video, and share my video with your friend and your colleague and your classmates. So our next lecture, lecture number 7, in that we will discuss about chloride of period 3 element. In that we will discuss chloride of period 3 element.